Hello, this week you will be working on Lab 9, Mirrors and Lenses. So in this video, I will give you a brief explanation about mirrors and lenses and also a couple of hints in order to complete the pre-lab questions. Well, let's look at what are the mirrors and lenses that we're going to use in this lab. So specifically, we will be focusing on two types of mirrors and two types of lenses. So the first mirror is the concave mirror. So in this picture, you can see a concave. So it is a cave-shaped mirror. And this gray color side is the back side of the mirror. The front side going to be on this side. So it is caved shape, right? So we call this as the concave. And it is a mirror, so we call this as a concave mirror. And convex mirrors are opposite to that one. And here, this side, the gray color side is the back side of the mirror. So objects will be on this side and you are seeing from looking through the mirror from this side. So we call this as the convex. So look at this. It's kind of a upside down of the concave mirror, right? So mainly we are using this concave mirrors and convex mirrors in our day-to-day life, and concave mirrors are using in bathrooms to see things bigger, and also the in dentals, right? So those are a couple of examples of uses of concave mirrors. And the convex mirrors, the best example is the side mirror of your vehicle. So using the convex mirror, we can see a big range using the small size convex mirror, right? So in the pre-lab questions, we will be learning about concave mirror and convex mirrors, specifically how to use the mirror equations. Then in the experimental part, we will be working on concave lenses and convex lenses. So concave lens comes in this shape, and the best use of concave lens in our life is with the people who are nearsighted. So to correct the nearsightedness, we are using these concave lenses. So especially when we're getting older, our muscles get dried up. So almost every people who, when we are getting older, we get this nearsightedness, and we will be using concave lenses in our eyeglasses. Then the convex lenses comes in this shape, and the best example, I would say, the magnifying glass. And also we are using these convex lenses in our eyeglasses if we are suffering from farsightedness, right? So to correct the farsighted, we are using convex lenses. So again, we will be applying the mirror equations and magnifying equation in the experimental part for lenses. Well, so there are two types of images that can be created using these mirrors and lenses. Those are called the real images and virtual images. So real images, the images that can be obtained on the mirror are called the real images. Okay, so example is images formed on a cinema screen. So here's the candle, and we have a lens here, and we can focus that image onto a screen. Okay, so here's the screen, and you can see the image on the screen, and it's made out of real light. So the real light rays travels through the lens and collected on the screen, creating the real image. And on the cinema screen, we are using a concave mirror, and the light is focused towards the screen, and images are created on the screen, and those are real images because it's real light travels onto the screen and create the images. Then the virtual images are the images that cannot be obtained onto a screen, right? So these are virtual images. For an example, when we are looking through a plain mirror, like if you're looking at your face, or if you're looking something else in front of the plain mirror, for an example, the light rays that's coming from the object will travel to the mirror and then reflected back onto our eye and creating this virtual image on the back of the mirror, right? So as you see here, these are dashed lines that represent, it's really the light rays are not traveled there, but it's virtually traveling, right? We see, it seems to be coming from the back of the mirror. So these are the virtual images. All right, so in the lab manual, you will be seeing two equations. So the first one is looks like that. A lot of notations, but you don't need to be scared on this one. This equation is called the mirror and lens equation. And let's understand what are these notations representing. So 1 over d naught. This is the distance from the mirror or from the lens to the object. Okay, so we call the distance the objective distance. Okay, then plus 1 over di, that's the distance from the mirror to the image. So you are measuring the distance to the image from the mirror or from the lens. And 1 over f, f is the focal length of the mirror or the lens. Then the magnification equation is m equal minus di over d naught. Di, again, the distance from the mirror to the image, and d naught is the focal length. Okay. Now here we see a negative sign. So if we end up getting a negative magnification, that means it's whatever the mirror or the lens is providing a inverted image relative to the object, upside down image, right? And if we get a positive value here for the magnification, then it's corresponding to an upright image. Okay, so when you're working on the lab, you will be seeing like your magnification numbers can either be positive or negative. So if you get a negative number, that means the image is inverted. Okay, so let's look at this problem. Remember that this is not the exact same question on the pre-lab, but it's very similar to the pre-lab question number 2. So make sure you learn it first and work on your pre-lab questions. So let's look at this question. So an object is placed 6 centimeters from a concave mirror with a focal length 4 centimeters. Find the distance of the image di from the mirror and the magnification of the image. All right, so let's understand the picture, right? So here we have a concave mirror. That is true, it is caved, right? So it is a concave mirror, and O represent the object, I represent the image. So what is di here? Di is the distance from the mirror to the object, right? So that's the di, and that value is given. Did I pronounce it incorrectly? So that is the distance to the object, right? So that is d naught, because this is the object. So you're measuring the distance from the mirror to the object. D naught, that is 6 centimeters, right? That's what it's given here. So D naught is 6 centimeters. Then that's the focal point. So the focal length is measured from the mirror to the focal point. So that value also given as 4 centimeters. It is a positive 4 centimeters. And then it's asking us to calculate the DI. So DI is the distance from the mirror to the image, right? So here's the image over here. So if you measure the distance from the mirror to the image, that's called the DI, and that is what we are looking for. Now you were given with 2 equations, and you can use the mirror equation, which is represented by this one, 1 over d naught plus 1 over di equal 1 over f. So here we know 2 things, and there's only one unknown. And in the equation, there are 3 unknowns, and we know 2 of those. So we should be able to solve for the unknown value, right? So let's substitute the numbers. D naught is 6. So 1 over 6 plus 1 over di, because I don't know di yet. That's what I'm looking for, equal to 1 over the focal length is 4. All right, let's do a little math. So I need to solve for di. So what I'm going to do is I'm going to keep 1 over di on one side of the equation by itself, and I take the other factors to the other side of the equation. So I get 1 over 4 minus 1 over 6. Now you need to solve for these fractions. So when you're subtracting 2 fractions, you need to think about the common denominator. It's going to be 24, and 6 minus 4, so it will be 2. So it will be 2 over 24, and it's 1 over 12. So now remember, di is not equal to 1 over 12. It's 1 over di is equal to 1 over 12. So you need to solve for di, right? So you need to get the inverse. So di is equal to 12 centimeters. Okay, so the distance from the mirror to the image will be 12 centimeters. Are we done yet? No, it's still asking the magnification of the image. So we need to use the other equation that's given. The magnification equation, which is minus di over d naught. So we found that the di is 12 centimeters. It's positive 12 centimeters. And d naught is 6 centimeters. So 12 divided by 6, it will be 2 minus will stay the same. So magnification is minus 2. Now let's check this whether this minus sign agree with our picture here. This is the object, so it is upright, right? And here image is inverted. It's upside down, right? So negative value of the magnification represent a inverted image. Yes, so it is agree, right? Just in case if you got a positive value, then the image will be upright one. Okay, so here the focal length is 4 centimeters and we found that di is 12. So we know all the three quantities on the equation. All right, so thanks, and I'll see you in the next video where I explain the simulation and walk you through the experiment.